So yeah, it's me, Chili, and we're gonna do another lesson. But before I start the lesson, I just wanted to say thanks to you guys. Thanks for liking my video here. I think it was lesson. I don't remember what it was, like lesson 9 or something, where I asked you guys to click on the like for my lesson 1 tutorial, and you guys did a lot. Well, some of you guys did that, and that's cool. I've seen an increase in the traffic for videos, and it's all good. Good for me, good for you. Alright, so let's cut with the bullshit and get to the chase. What are we going to do today? Today we are going to make a tic-tac-toe game. I know that's what you guys have been, wanting to do. As soon as I started this tutorial, you all been like, oh man, I really hope he does a tic-tac-toe game. And your wish is about to be fulfilled. So, tic-tac-toe. What the hell is that? Okay, I got the wrong brush on here. Wait a second. I gotta deselect this now. There. Okay. Again, tic-tac-toe. You get a grid. Looks like this. Yeah. Your pound sign there. And you put X's and O's. I don't have to explain tic-tac-toe, do I? I don't think so. So yeah, we're going to make that. Now, to draw tic-tac-toe, you have to be able to draw straight lines, and you have to be able to draw circles. And it just so happens to be that in the last 2 tutorials, we developed the code to be able to do that. We wrote 2 functions, one to draw straight lines and one to draw circles. Funny coincidence, isn't it? I think that was under D3D graphics. Yeah, here we go. So we got our draw line function here, and we got our draw circle function. And you should have that all squared away, because if you don't, you're fucked. But you can go back to the videos and you can look it up and copy and do whatever. I don't care. But you got to get yourself these functions in your D3D graphics object. Okay, so we got our game here, and at the moment it's just basically a simple demo to test out draw circle, I guess. So we're going to get rid of that because that's not important. And we'll get rid of X and Y for the moment. We're going to be resetting our game source files to their default whatever. Okay, so we need to make a tic-tac-toe game. So the first thing, there's a lot of ways we could go about this, how to go about making our project, where to start. I'm just going to start wherever the hell I feel like it. And where I feel like it is I'm going to start by saying, okay, well, first thing, we're going to need to draw a tic-tac-toe grid. So let's write a function that will draw our grid on the screen. That's how we're going to start off this project. Yes. Okay. So we'll put this function in the game object because it's not really a general graphics drawing thing that you'd want to use in any program. It's just very specific to the specific game. So we will put it in the game object. Okay, so we need void draw. I'm just going to say everything. Nah, we'll just say draw grid. And we'll make it so that we can adjust the base position where the grid is drawn on the screen. However, we will not make the size of the grid adjustable, so the size will be fixed. We're just going to allow the caller of the function to determine what point on the screen the top left-hand corner of the grid will be at. Alright, so we need to make some decisions here about our grid. We need to think about how big we want to draw it and stuff like that. So I'm thinking that the size of one cell in our grid should be 100 pixels by 100 pixels. Alright. So let's say the top left hand corner here of our grid is at 0, 0. So if we count 100 pixels down, this point on our grid would be 99. That's a 9. And this point here would be 199. Alright, same deal here. 99, 199. And this last pixel on the grid here would be 299. So one cell in the grid, for example, this top left-hand cell, would include all this white space plus this section here. And same thing here, and like that. I'm not sure if I'm explaining this very well, but you'll see, you'll get the picture. The gist of it is we want 100 pixels wide and 100 pixels tall. Yeah. So, well, let me think here. Let's get out our code. We're going to go to game.cpp and we'll do void game draw grid x, y. Okay. So to draw the grid, it's fairly straightforward. You need 4 lines, right? 1, 2, 3, 4. We draw our 4 lines and we're done. So we do graphics.draw line. So our x1. So our first line, let me just go back here. Ah, you cocksucker. There we go. Okay. This will be our first line. This will be 1, 2, this will be 3, this will be 4. Draw 1, 2, 3, 4. So our first line will start at x equals 0 and it will end at x equals 299. Right? That sounds about right. So we want 0. Now I'm doing plus x because we want to be able to adjust the position. So the base position is 0 plus whatever x and y the caller passes to the function. y1 will start at 99 plus y. What's next? Okay, now x2 is 299 plus x, and y2 is again 99 plus y. That doesn't change because this is a horizontal line, right? So the y values should not change over the course of drawing the line. Alright, so we're just going to do this crap for everything. 2, 3, 4. Delete that. Okay, so the second x will be at 99. No, that's wrong. Don't listen to me. I'm crazy. I better look at this here. The second x will start at 0 and go to 299. But the y this time will be starting at, or will be set to 199. Okay. So, again, 0 to 299 for x, and 199 to 2... No. I'm going to screw something up here, I know it. Alright, now we're going to draw vertical lines. So again, we'll start off at x equals 99. This time is at 99. And it will end at 99 because x is not changing this time. It is the y that is changing. Y will go from 0 to 299. Now our x is at 199 and it remains at 199 and y goes from 0 to 299. Yes, this seems like it's what I want to do. It's probably gonna totally fuck up. Alright, I didn't even... Okay, what's your problem? Ah, right, we need colors. I forgot about the colors. Okay, we'll just make it white. White sounds good to me. I'm getting hungry. Okay. Build. Alright, at least we didn't get any build errors. Let's test this out. Every time you, when you're making a program or something, it's very good to build it, to write small parts, and then test them right away, instead of writing the whole damn thing and then putting it all together and testing it. Because if you do that, there's going to be so many fucking bugs, you're never going to figure out what's going wrong where. So always incremental baby steps. Write a little bit of code, test the code. Write a little bit more, test it. Then take the parts that have you written, put them together and test them. And lather, rinse, repeat. Okay, so draw grid. We'll just draw it at 0, 0. We'll see if that works. Build. And start. Alright, and that does appear to work just fine. Looks nice and square and balanced and good. Alright. Let me just do a little test here. So the screen is 800 wide. The midpoint is at 400. Minus half the width of the thing, which is 150, 250. Can you guess what kind of calculation I was doing there? Now the top's 300, so this one should be 150. This should put it at around the center of the screen. Just want to make sure that my positioning stuff is all good. Yeah, that's about the center of the window. Alright, good times. So that is our grid all done up. What is next? Well, I guess we could write the functions that draw X and O on the screen. That wouldn't hurt, would it? Nah, I think that's good. Okay. So, more drawing functions. Void draw X. Void draw O. Yeah. Okay. If I was smart, I would do this. And then this. Ah! It's all tabulated. It's all tabified. There we go. Okay, so this is pretty straightforward, right? You get up there. Ah! I hate this keyboard. Okay. So, draw X. How are we going to do that? Let me see here. So, we want blah, blah, blah. Where's my Photoshop? Here it is. So, I want to put an X in a square. We need to figure out the dimensions of the X. The X should be a little smaller than the cell, just because I think that will look prettier. So I'm going to say that I want about 15 pixels between the top left-hand corner of the cell or the top of the cell and the top left-hand corner of the X. So we'll get a little leeway here. So we want draw a box around our X, and we want about 15 pixels from our X to the edge of the cell. Yeah, I think that's about right. So, to make a long story short, undo this. I just copy and pasted that from somewhere else. Yeah, so X is the position that we're drawing the X at. That's awkward. And we're adding 15 because it should be, you know, it should be padded. It should be padded here. So yeah, 15. So for example, if we're drawing this line here, we want to go from the point 15, 15 to the point 84, 84. It'll give us a nice diagonal line, nice 45-degreer. And that's what we're doing here. The colors, we're just going to set the colors. X will be red. So we'll give her 255, 0, and 0. Alright. And that will give us our X. For the O, we'll get the same deal here. Just going to copy this. Because I've already actually written this program. I did so to do demonstration and to do demonstration for the homework and stuff like that. So I've already got this program written. I'm just going through it again for you guys. The things I do for you guys, you have no idea. All right. The O's are going to be blue, so we'll switch it up a little bit. And we're just drawing our circle at the smack dab of the center of the cell, so we'll just put the center of the circle at 50 and 50. And the radius is 35, which gives us, again, 15 pixels of buffer room. Padding, if you will. And now we can draw our circles and our X's. So let's try this. We will draw our grid at 0, 0. That's easiest. And then we're going to draw X at 0, 0. And we're going to draw Y at 100, 100, which should be the center. It should be the center cell. Build and get errors, or yeah, errors. Draw Y, okay, why did I say draw Y? It's a draw O. You get that jammed in your head. X and Y, A and B, J and K. Alright, what's this? Graphics undeclared identifier. What? Where am I? I'm in game. Okay, what's the problem here? Ah, I got you. I didn't specify that these functions are members of the game object, so gotta tell you everything, don't I, compiler? No independent thinking skills at all. Alright, so here we got our X and our O drawn pretty much in the middle of the cell. It looks pretty good to me. The O looks like it's a little off to the right, but whatever. What's this one? This one looks like it's actually well balanced, I guess. Let's try 49. It's my OCD kicking in here. Pay it no heed. Let's try that again. I meant to do start debugging. That O looks a little more centered now. That looks better for me. I'm happy with this. Alright. So now we can draw our X's and we can draw our O's. Alright, so we got our basic functions now to draw our game screen. Now what we're going to have to do is we need to work on the model of our game here. The model is like the simulation part of the program. It's how we represent the actual state of the game. The drawing code, this is just the view. This is just the eye candy, right? Now we actually have to work on how we're going to store and process the internals of the tic-tac-toe game. So, tic-tac-toe game, you can describe the state of a tic-tac-toe game, game position, by describing the state of each of the cells here. So, let's see if I can't Control Z my way out of all this garbage. Thank God for deep history. Here we go. Okay. So we've got tic-tac-toe game has 9 squares. So we'll call them S0, S1, S2, and so forth. 4, 5, 6, 7, and 8. So S0 to S8. 9 squares altogether. And each of these squares can have, it can take on one of 3 states. It can be empty, it can have an O in it, or it can have an X in it. So how we can do this is we can create 9 variables, S0 to S8. And each of these variables will store the state of its respective cell or square. Now, the question here is how do we how exactly do we represent the state of a cell in a variable? Because the variables that we use, we know ints and floats, right? They're numbers. But these aren't numbers. These are like symbols in a box, or lack of a symbol. The answer is we just we can just decide that okay, if we're using int for our variable type, int s0, well, if the value of s0 is 0, then it's blank, and if it's 1, then it's an X, and if it's 2, then it's an O. So we just arbitrarily assign meanings to these values, and anything else, so like a 3 or a -1, all this is just crazy poop that we don't care about. That's just bullshit. That doesn't make any sense. The only valid values for these variables is 0, 1, and 2. And we can do that. That's very simple. The only problem with this is that your code is going to look kind of stupid, because you're going to have stuff like, let's say we want to check to see if there is a line of X's here. So we would do, for example, if S0, that's a stupid 0, if S0 equals, let's see, X is 1, right? And if S1 equals 1 and, ampersands, they're hard. And if S0 equals 1, and then we do something like X wins or something like that, right? But if you write code like this, it doesn't make a lot of sense. Like, people are going to look at this and say, what's 1? What's the significance of 1? It's just a number. 1 what? I don't get it. So that's the I'm going to change this here. That's the downside of just randomly assigning an integer value to a state. It's not good coding practice, because it makes for difficult to read code afterwards. We would like, for as much as possible, we would like our code to be self-documenting, so you don't have to look at some kind of explanation or comments. Just looking at the code itself, we should be able to understand what the hell it does. So we're not going to use integers to represent our the state of our squares. We're going to use something else. And I'm going to put it right here. No, I'm not going to do that. So I'm going to add a new section here. It doesn't matter. What I'm doing here is not a big deal. I'm just separating the declaration of our functions here from the declaration of the thing I'm going to declare now, which is what we call an enumeration. Put a semicolon at the end there. Don't forget that semicolon. All right. So this is important. So copy this stuff down here. Enum, or enumeration, XO state, and then open brackets, close brackets here with the semicolon at the end. And inside we have 3 lines here, empty, X, and O, separated by commas. This is effectively creating a new variable type. Now the name of the new type is called XO state. And XO state can have 3 values, empty, X, or O. And we can use this new variable type to declare some variables. So now we can do XO state S0. And I'm going to create state variables for every one of our squares. So 1, 2, 3, 1, 2, 3, 1, 2, 3. 1, 2, 3, 4, 5, 6, 7, and 8. All right. So now we have one variable for each of the squares in our tic-tac-toe game. And these variables, they can only take on the values, well, theoretically, they should only take on the values of either empty, X, or O. We'll see how this works in a little while. So yeah, now we have this. We've got our square states there. Now we're going to do something a little different. We should initialize our square states. So we should go in here and we should say, for example, S0 is empty. And we should do that from S0 to S8. But I'm not going to do that because I have a little plan. What we're going to do here is we're going to write some functions to access our variables. So I'm going to go void set square state and index XO state. So this function is we're going to call this function when we want to set the value of one of these variables. Now you might ask yourself, why would we want to call a function for that? Why don't we just go S0 equals empty or something like that? You will see in a second. It will all become crystal clear. Game set square state. I kind of fucked that up a bit, didn't I? Yeah, okay. It's all good. I saved it. Ah. Okay. So this function will allow us to set the value of any one of our square states, but it'll allow us to choose which square state we want to access by a index integer. So depending on what value of index we call set square state with, set square state will change the value of one of our square state variables. Now I'm going to show you something else new, because I'm actually showing you a lot of new stuff in this video. New thing number 2 is a switch statement. Now a switch statement is actually a hell of a lot like an if statement. It's a conditional, so it depends on the value of the switch variable here. Let me just show you how this works. So case 0, S0 is equal to state and break. Case 1, S1 is equal to state. Break it. It doesn't mean like break your computer or go breakdancing. It's just it means skip out of the switch statement. I'm going to take a shortcut here. I'm going to copy and paste from my other code, stuff I've already finished, if I can find it. Set square state. Yeah, that's the one. Okay. Control C, Control V. All right. So I'm sure the astute of you will have already guessed how this works. But basically, what a switch statement does is it looks at whatever is inside these brackets here, and it jumps to the case which has the same value. It only works, I think it only works with integers actually. I'm pretty sure that's the case. And yeah, so I mean, if we call set square state and we want to set S4, we'd call set square state 4. And let's say we want to make it empty. So we'd call it with 4 and empty. We'd hit the switch statement here. We'd switch on a 4. It would jump here. And it would move the state value, empty, into 4. And then it would hit break, so it would jump all the way to the end here. And that's how it works. It's quite simple, really. One thing, make sure you put in the breaks. It is so easy to forget these breaks. And if you forget one break, what'll happen, let's say we don't have a break here, and index is equal to 1, it will jump to case 1, and it will set S1 equal to state. But then it will just keep going. So it'll go down to S2 is equal to state, and it will also set S2, which is not what you want to happen. And then it will break. So if you don't put in your breaks here, it'll just run all the way down. It'll jump to wherever the case is, and then it'll just keep running. So you got to make sure you got these breaks at the end of your case. There are situations where you don't want to break, where you actually do want it to fall through to the next case, but generally you want to break it. And last thing here, there's also a default case, so if the index doesn't match any one of these cases, it will jump to the default. So you can add a default case if you want. You don't have to, but if you add a default case, it will jump here, and I mean, it's not really useful. If you don't have a default case and it doesn't match up to any one of these cases, it just jumps to the end anyways, so not a big deal, but it can be very useful sometimes to have a default. Alright, so this is our set square state function. Now with this function, we'll be able to do something useful. Let me just build to make sure I haven't fucked anything up. Good, okay. Now remember I was saying before how we have to initialize our S variables, right? And that would be a pain in the ass, right? Having to type 0, S0, S1, S2, S3. Now, we can access our state variables by index. And this lets us do something very special. I'll call it index. I'll call it x. I use x too much for my loop variables anyways. Index is equal to 0 as long as index is less than 9. Index plus plus. And here we just do set square state index, and we want to set them all to empty, so empty. And these, well, 2 lines really is all we need to initialize all of our s variables. So having this access function will allow us to access any one of the variables with an integer value. And it's very convenient. But we're not finished. Here we have a function that allows us to set the state of a square. But it stands to reason that we will also want to get the state of a square. Now, I'm not sure if we've actually created one of these functions yet. If you remember, when we were drawing our circle, we used the square root function, right? And that function took a value, but it also returned a value. And we're making one of those functions now. I think that's the first, this is the first one of those kind of functions that we're making. They're very momentous. Oh, we don't want it to be an int. We want it to be a XO state. So here, our getSquareState function, we pass it an index, and it gives us, it returns, it poops out the value of the state of that index. Alright, so, and it's basically the same deal, really. Let me just copy this. Now we have to put game in front of XO state here. Why didn't anything pop up? That was weird. Okay, there we go. And we got to put game in front of this one. So we got to put game in front of XO state just here. I won't bother to explain why. It's not that important. We'll get to that later. At a later date. Has to do with scoping and stuff like that. Boring stuff that we don't want to talk about right about now. What we do want to do is get square state. Okay. I'm just going to copy and paste again. There we go. So, here we have a little different story. Again, we're using a switch to determine our behavior based on the index value that was passed to the function. And what we're doing is we are returning the value of the requested square state variable. So we use, I don't think we've used this before, but the return keyword here. And when you hit the return keyword, you automatically exit the function. And you exit the function with the return value that is stated after the keyword. So because we are exiting the function, we don't need a break. We don't need to put a break in here, right? Because it will never get here. As soon as it hits here, it'll return and it'll exit the function. So here's another case where you don't really need to write the breaks in. So here it returns the value of whatever variable corresponds to the index value. And if the index is not one of 0 to 8, then just return empty as a default behavior. So this will return the XO state of the requested square. Easy enough. Why isn't this letting me smallify this function here. That's pissing me off. I want to collapse you, but it was not to be. Alright, let's try and build this again, make sure I haven't screwed anything up. And I did screw something up. Something's wrong. My copy and paste kung fu is... There we go. That's why it wasn't letting me collapse this one. Alright, let's try building that again. And that worked. So now we can get the state of a square, and we can set the state of a square. Alright, so we got our square accessing functions here, and they're all fine, they're all good. They let us access our squares by linear addressing, which is to say we give them a number, and they, for example, 4, and it will give us the value or the state of square 4, right? So it's kind of like a straight line, 0 to 8. But what's often useful in a situation like this is when we're playing the game, the way we actually look at it, it's laid out in in rows and columns. So what we might want to do is we might want to be able to address our squares by row and column. So we could address a square as S4. Its linear address is 4, but its row and column address is 1, 1. So the square at 1, 1 is S4. So we are going to make a function so that we can also address or also access our squares in row and column format. So let's get on that. So we need to add more functions. We're going to have a lot of functions when we're done with this tic-tac-toe game. Alright, so void set square state int ix int iy and xo state. Now you might be thinking to yourself, wait a minute, we already have a function called set square state. You can't use that name over again. The answer is yes, I can. Because I'm the chili, and because C++ lets you do that. Now you might wonder, well, how does the compiler know which one to call then if they both have the same name? And while they do have the same name, they have different parameters. So depending on what parameters are passed to the function, the compiler will know whether to call this one or whether to call this one, right? So a function is not identified by only its name. It is actually identified by its name plus its parameters. And a function name plus its parameters together is called the signature of the function. So signatures are all unique. You cannot have the same signature. I cannot have set square int and xo state. But I can have a set square that takes an int and an xo state, and then another set square that takes 2 ints and an xo state. That's fine. The signatures are different, so they are treated as different functions. This is actually called function overloading because we're overloading the one name. But in reality, they're actually different functions. Generally, when you overload a function name, it's going to do about the same stuff. You wouldn't have two completely unrelated functions having the same name. That would just be confusing. So, void game set square state. And we want int ix, int iy. I'm just going to copy and paste this. All right. So what we're actually going to do is from our our row and column set square, we are going to call our linear index set square. Sound confusing? Not really. It's not a big deal. Now the thing that we have to do is we need a way to convert from linear addresses, for example, a way to convert from 4 to 1, 1, or actually to convert from 1, 1 to 4. And how we do this is simple. If you look at our grid system here, our grid has a width of 3. So every row has 3 items in it. And if you look at the beginning square in a row, it starts off as a multiple of 3. 3 times 0 is 0. 3 times 1 is 3. 3 times 2 is 6. So to get, first of all, to get the first item in a row, you take the row number. We'll call this y. So y specifies what row we're talking about. So you take the row number and you multiply it by the width of your grid or your table. So the width of our table is 3. So, let me try this again. Here we go. So y times 3 will give us the address of the first item in a row. And then you just add your x value to that. For example, if x is equal to 0, then you want the first value. So it would just be 3 in this case. But if x is 1 or 2, then you would just add 1 or 2 to this value, and you would get your final item here. So what you do is you have your row number. Your row number is y. Your column number is x. You take your row number and you multiply it by the width of the table. And that will give you the item in the number of the item, the first item in that row. And then you simply move over x columns. So you move over x items until you get the one you want, which is the one at xy or yx or whatever. I have a feeling that I have completely bungled that explanation. It's not that difficult, really, but yeah, it's just you take your y. This is your y, right? And you multiply it by 3 because our table is 3 wide. So moving down, well, if your y is 0 here, then you're at item 0. But if you move down 1 y, you have to go 1, 2, 1, 2, 3 over to get down 1, right? So you have to add 3. And if you go down again, you have to add 3 more. So it's just y times 3. However many down you go, you just multiply that number by 3 because there are 3 items in every row. And then just to move over to your correct column, you just add your x coordinate. I hope that makes sense. Anyways, this is actually really, really important. So, yeah. If you don't understand this, it's going to make some stuff that's I have to talk about later on way more complicated. I hope this makes sense. This is like a total disaster now, this diagram. So anyways, let's try to put this into code. So int index is equal to IY times 3 plus IX, right? That will just give us our flat linear index based on our row and column numbers. X is our column number, Y is our row number. And then once we have our flat index, we can just call our set square state function. Now, because we've overloaded set square state, if you look at this tooltip, it gives us two options because there are two different functions with that name. So that's handy. We want this one. You don't have to click it. You just have to type it in. It's fine. Which is our flat index, and then the state, which is just coming from here. We just pass that right on to the linear addressing set square state function. So we just pass the buck with that state, but we have to convert from our row and column into our flat index. And the same deal will happen with our just gonna copy that. Yeah. Int ix int iy get square state. I have a feeling that this could have been. Oh, that pisses me off a lot. Huh? Okay, there we go. Whew. All right. Yeah, so we got get square state here, and do that. Make sure it's part of the game object. Get rid of the semicolon, and just do the same stuff. Convert our coordinates and call. Okay, we want to return the return value of get square state. Which is just with our flat index. So here we convert our indexes, and then we get the square state of the linear index, and that return value, we just pass that on. So it's kind of like a function inside of a function. This overloaded function wraps around our original function and just gives us the option of converting from columns and rows into linear indexing. So it's just extra tools for our toolbox here. Let's see if this works. And of course it doesn't work because I screwed something up. Missing something. Get square state. What is your problem, jerkface? Now you're pissing me off. Oh, right. That's right. I have to put game in front of here. Weird. Okay. Build. Ah, that worked. Whew. Alright, so now we can access our members by flat index or by rows and columns. So the next step in our project here is we want to be able to this is so messy. We want to be able to read the state of our state variables, and based on our state variables we want to draw the tic-tac-toe board on the screen. So the first thing we're going to do, I'm going to create some constant variables here. Constants are just variables whose values can't change. So important numbers there that don't change, instead of just coding them hard in, like the number 350 or something. I think it was 350, wasn't it? Let me think here for a second. And by think, I mean look at the one I already wrote. All right. So base x is equal to 250. These are just the base coordinates of our tic-tac-toe grid. So instead of just hard coding in the numbers 250 and 150, I'm going to create variables so I can refer to them by name, because names make things easier to read. And I'm making the variables constant because we don't need to change these variables. So if a variable doesn't change, you should make it a constant. The reason for that is that you might make a mistake and change it somewhere by accident. And if you did that, that might fuck your program up. But if you made it a constant variable, then the compiler will say, hey, you're not supposed to change that, dickface. And it'll let you know that you're being a total derp. Yeah, so constants. We'll use them more often later on. So we have the base. Now what we want to do is draw our grid at base x and base y. Now we want to draw our x's and our o's. So here's what we'll do. For int I y, yeah, is equal to 0, as long as iy is less than 3, iy plus plus. We're looping through our rows there. I always get rows and columns mixed up. That shit's hard, yo. iy is less than 3, I mean x. Now this is our inner loop, so this is the loop that we'll be looping through first. And it's looping through the x's, so it's going from left to right. And then when it hits the end, then we go down a row. Yeah, that's what it is. That's the ticket. And so this is going to loop through all of the squares on our tic-tac-toe board. And for every square, what we want to do is I'm going to add another constant here. Square size is equal to 100. Just because. It'll make things look prettier. So for every square, I'm going to put an if statement in here. If get square state at ix and iy is equal to x. Remember, this x is the a value for the enum, right? Enum game. It's a state value. So if the state of the square ix, iy is equal to x, then we want to draw an x at base x plus x times square size. Wait, I meant ix. Right. So I mean, if our index is 0, then we'll draw it at the 0 times square size, which is 0. We'll draw it at the base position. But if our x is 1, then we'll draw it 1 square over. Or 2, draw it 2 squares over. Capiche? And base y plus iy. I said plus, you dickface. I may not have typed plus, but I know I said plus. Square size Yeah. So if the state of the square ix, iy is x, then draw an x at that position on the screen. Fair enough. Else, if, I'm just going to copy this because I'm lazy. And if it's equal to O, I didn't type Y that time. Are you proud of me? Are you proud, mama? Then we want to, we can just copy and paste this too. Because this is exactly the same, except I'm going to draw an O instead of an X. Alright. So if it's an X, draw an X. Else, if it's a Y, I said Y. I said fucking Y. If it's an O, draw an O. And if it's neither of these things, then do nothing. Which is good, because we don't want you to do anything. If it's not an X or an O, then it's probably empty. So draw nothing. So we draw a grid. We loop through all of our squares and draw their states. Build. Oh, we had success on the first run. Start debugging. Alright, so we have nothing, but that's fine because we initialize all of our states to nothing. So we shouldn't have anything. If we have something, then that's bad. That's wrong. So let's do something in our, what do you call this thing? Constructor. So we'll set the state of our middle square to x, and set square state 2 to O. Okay, we'll set two of our squares up here, and they should appear on the screen now. They did. Not where I wanted them to, but I fucked it up. Yeah, this is the Y, so Y is 2 and 0. Yeah, okay, that makes sense. Alright. So here we have 1, 1, and we have an X there. And here we have 0, 2, and we have an O there. Perfect. Beautiful. Alright. So now we have our code for rendering our game table thing. Game board. We render this every frame. But we still have a ways to go. We have no way of the user, providing input, doing stuff, changing the squares themselves. We've got to get on that shit. So, the user, you could think of a number of ways for the user to interact with our model here. One way would be mouse clicks, but since I haven't actually done mouse stuff yet, we'll do that later. We're going to go with the keyboard. And if you use the keyboard, you need to have a way of showing the user which square is currently selected. So what we need is a kind of a cursor. We're going to make a cursor like this. And that'll show which square is currently selected. The user can use the direction keys to move the cursor. And then when they press enter or space, it will put down a symbol, an X or an O, at the position where their cursor is. Fairly straightforward, fairly intuitive. So we need another draw function. Game.h. Void draw cursor int x int y. We'll copy this mofo. And we'll slam her down over here. Okay, so we need to draw 4 lines for that, and it's not that big of a deal. I'm just going to copy and paste from my already finished code here. And the cursor, what color should the cursor be? I can't even remember what color I did it for in the... Let me see. That's not it. Let's try this one out. Okay. Yeah, sure. Run it. It was green cursor. Okay. So, we'll make it green. Be consistent. Green is the one in the middle. So we'll do 0, 255, and 0. Copy. So yeah, you can just use these numbers if you want to make the cursor or whatever. I don't care. It's not a big deal. I just put the cursor somewhere within the padding region that's between the X and the O and the actual border of the cell. Not a big deal. Now we can draw our cursor. Alright, what we're going to need now, so we're going to need some variables to keep track of where the cursor is. So we'll do int cursor x cx. Yeah, we'll do cx. That's easier for me to type. Although it is more difficult to understand. CX it is. I'm a lazy programmer. And we need to initialize our CX and CY. We'll initialize them to 1. That'll start off the cursor in the center. Seems like a good idea. Okay, now what we need is let me think here. No, you know what? We're not going to be lazy. Cursor X, cursor Y. And I'm going to tell you why we're not going to be lazy. Because by not being lazy, we are going to be lazy. Because I already wrote this code, and the way I wrote it, it uses cursor X, cursor Y. And I don't want to have to change that crap again, so... Okay, so we have code here. And let's get rid of this stuff. We're not ready for that yet. You guys aren't ready. So here's our standard keyboard code, right? If a button is pressed, for example, if right is pressed, increase the value of cursor X. And if cursor X is outside of the bounds, which means if it's greater than 2, then set it to 2. We don't want a cursor going off the end of the screen or something. That would be unfortunate. So this will allow us to use the keyboard to control our cursor. Now we have to draw our cursor. So let's draw it here. Draw cursor. That'll just be base X plus cursor X times, was it square size? Yeah, square size. And copy, paste, switch out the X and the Y. Okay. Now if we do this, we should be able to have a cursor, and we should be able to move the cursor. And we failed miserably. Cursor XY? Yeah. That's not happening. Try again. Still failing. Fail sauce. See, right, because I changed. Cursor X. Let's try again. Still failing. Graphics is undeclared because I didn't make it a member of game again. And finally, start debugging. Alright, so now we got our cursor. And if I press my arrow keys, I can move my cursor here. Okay. And now you see the problem with this. So because it checks the button state every frame, and we get 60 frames a second on my computer, that means that you have to have really freaking fast reflexes if you want to get this thing to stop in the middle. It's pretty much impossible. You can try it if you want, but it's not happening. So this is a problem, unless you only play on the corners, in which case it could be okay, I guess. But if you like to play anywhere other than the corners, you're going to have a problem. And yeah, so how are we going to solve this problem? Like I said, the problem happens because this compose frame function, where we draw our frame, is being called about 60 times a second. So if the right key is held down, it's just going to keep running through, and it's going to keep going right until it hits the end of the screen. And it's going to do that like really damn fast. So what we want to do is we want to register single key presses. A full key press is when the key is pressed and then released. And that counts as one key press. So if the key is pressed, it should move over once. But it shouldn't move over again until the key has been released and pressed again. So that means we're going to have to keep track of some crap. So I'm going to show you how I will do my solution to this problem. There's a bunch of ways you can solve it. There are better ways to solve the problem. And I will show you some of those better ways in the future. But for now, this will be a good solution for us. We're creating a Boolean variable, keys pressed last frame. So this variable will be true if any keys have been pressed in the previous frame. False. So anytime a key has been pressed, we say, yeah, keys pressed last frame. We set it to true. So, first thing we do is we check. We check whether any keys have been pressed last frame. And if no keys were pressed, then we can go ahead and process our key input. But if keys were pressed last frame, then we're not going to process key input, because if we do that, we'll just be processing it way too fast and this cursor will jump around. So this is effectively putting a block on our key pressing. It only allows the keys to be processed once when a key is pressed, and after that it blocks it. And while it's blocking it, what it's doing is it's checking to see if all the keys have been released. So as long as the key is being held down, it will continue to block. And while it's blocking, it checks, well, I'll show you what it checks here. So this statement inside here is basically checking whether any one of the keys are pressed. And this negates that. So what it's saying is that if none of the keys are being pressed, then we say, okay, keys pressed last frame is false because no keys were being pressed in this frame. So in the next frame, this will be keys pressed last frame false. In the last frame, no keys were being pressed. And once that happens, then we're free again to check our keyboard input. And if a key is pressed, we handle the input and we block. Then we block the key testing. And while the key is being held down, it'll continue to block because keys pressed last frame will remain true while it's blocking. And then when the pressed key is finally released, it'll go here and it'll say, okay, no keys are being pressed, and it will unblock. So, yeah, that's what this is. Very simple. I mean, the key input part is very similar to what we've been doing before, right? I mean, with like the moving the poo around the screen, right? You move it, and then you check to see whether it's out of the boundaries of the screen. It's just we also add this extra line in here so that once we have determined that a key is pressed, we block the key input so that it doesn't continue to move over every single frame, because that's just too damn fast. And when we're blocking, we don't check any of the keys to see whether they're pressed in here. Instead, we check to see whether no keys are being pressed. And if no keys are being pressed, then we unblock. And we're ready to accept another key press. And by this method, we only accept single key presses. So for every single press, we get one motion. It doesn't continue to move to the right or to the left or whatever. Okay, that was a long explanation, but it's an important problem, and I know some people have already come up with this problem when they're making their own games. I've gotten questions on the forum, and this is one way to solve that problem. So, let's see if I haven't fucked something up here. Okay, so far so good. Now I'm going to press once to the right, and I'm holding the right key down, and it only moved one square. Now I release, press again, press and hold, and release. So, with this system, we can have very good control over our cursor. Not much to say. If you press a bunch of keys at once, it's kind of sluggish because it has to wait until all keys have been released before it unblocks. So if you press, for example, up and right at the same time, it will not move diagonally. It'll only move one way, and then it'll block. So it's not the best solution, but it is a workable solution. Alright, so here, this will allow us to control the position of our cursor. And last but not least, I mean, if we want to do it, just to show that we can do it, I'm going to put a simple line in here. If kbd dot enter is pressed, we're going to set square state cursor X, cursor Y. So we'll put an X wherever our cursor is if enter is pressed. So this should let us plop down a bunch of X's. And there you go. So yeah. So far so good for our tic-tac-toe program. The graphics side of it is going very well. Now we just have to get into a little bit more of the meat of the program. Alright, now I think we need a little bit more structure in our program. So what we're going to do is, first off, we're going to add another function. Oh, we love me some function. Alright, function name will be void. Do user input. We'll take a parameter of type XO state. I should copy that. And here we go. Okay, so do user input. This time I'm making sure put the game in front of that. Okay. So here we'll handle all the user input stuff. So I'll just copy, or I'll cut this X and V. Alright, that seems about right. Put that back there. Okay. Now, do user input. This XO state parameter will represent the current player. So I've been using XO state to represent whether it's an X or an O in the square, right? But I think I could also use the same variable type to represent whether it's the X turn player or X player's turn or the Y player, the O player's turn. So a little different use of the type, but still makes sense to me. Alright, so this part won't change at all. This is the same. Here though, if enter is placed, we want to set the square state to the type of the current player. So if the current player is X player, then we want to set the square to X, obviously. Seems rather self-explanatory. So we want to set the square if enter is pressed and if get square state at cursor X, cursor Y is equal to empty. So we don't want to set a square if it already has an X or an O in it, then we just want to leave it alone. You shouldn't be able to change a square once someone's written on it. That's called cheating. So we'll only set the square if enter is pressed and the square is empty. That makes sense. So here's our do user input function. Let's just test that out quick. Do user input, and we'll just say that the current player is always X. And it works fine. Alright, so far so good. So we just pulled that out into its own function. It makes it a little easier to understand. Now we want it to be able to change between the player being X and the player being Y. So we want turns to change over. So we'll do XO state. We'll do active player. We'll initialize that. Active player is, well, X goes first. I think that's how it works. Okay. Now, let's add another function. Void end turn end turn. Here we go. Okay, so for the end turn, what we're gonna do is, let's see if I got this straight here. Yeah. So if active player is equal to X, then active player is equal to, oh, that's not right. Oh, else it's equal to X. Very simple. Just flip flops the current player. And in do user input, when you successfully change a square, that's the end of the turn, right? So we'll put our end turn function call right after set square state. So this should allow, now we should alternate between X's and O's. So we got X and another X. Oh, wait. Okay, I got it. I have to do user input with the active player. I wonder if there's even a need for that. XO state current player. I guess I could just change this to active player. There's no reason to make that a... There's no real reason to make this a parameter. We'll do that. Okay, so we'll get rid of it here, and we'll get rid of it here. So it's just hardwired to work with the active player variable. Let's try that. All right, so we get X. Now they're X. God damn it. I must have done something wrong here. All right, let's see what I did wrong. Active player, good. Do user input. That seems good to me. And that's fine. Active player. Right. End turn is working. Ah, okay, I did something incredibly stupid here. Yeah, I think I told you guys never to do this. So this is good if active player is equal to, if it's the same as X. If it is X. And then here we're doing another test. And actually, yeah, won't happen. Let me just do a little change here. And build. It actually gave me a warning here telling me how stupid I was. Operator has no effect. Did you intend the assignment operator? Yes, I did. Yeah, so here I'm comparing active player and O, but I'm not doing anything with that comparison result. It's not inside an if statement or anything. It's just comparing and then forgetting about it. When what I really wanted to do was I wanted to assign the value O and the value X to active player. Stupid. Alright, now it should work. Okay, good. And I can't write over any spots here. Doesn't work. So we're getting our alternating X and O pattern. And we've prevented the program now from writing over any square that already has a symbol inside of it. So we're making progress here. What is next? Well, I guess the next logical step will be to check to see if... God, that's a lot of crap on the screen. delete that. Alright, good. Right, so we want to check. Find my... Ugh, something fell on the ground there. We have to be able to test to see whether the X player or the O player has won the game. So we got to check for victory. Now there are, let's see here, there are 1, 2, 3, 4, 5, 6, 7, 8 ways to win, right? 3 horizontal lines, 3 vertical lines, and 2 diagonal lines. So we have to check to see whether any of these lines are all X's or all O's. And if they are, then we have a winner. You are a winrar. So we're going to make another function. We'll call it we're going to use the XO state type again. And we're going to be check for victory. So the return value here will be X if X is a winner, O if O is the winner, and empty if there is no winner. Alright, so there's various ways we can do this, but I'm going to do it the well, in a matter of speaking, a simple way. Easy to understand way. Game XO state. Game again. And check for victory. Alright. So we have a victory if S0 is the same as S1 and S1 is the same as S2, meaning S0 is equal to S1 is equal to S2. And S0 is not equal to empty. Because if they're all the same, but they're all empty, that does not mean a victory for anyone. No one wins. It's a tie, you both lose. So we have to make sure that they're all the same and they're not empty. And if that is the case, then we have a winner. So return S0. Because if they're all the same, then it doesn't matter which one you return, whether it's S0, S1, or S2. They're all going to be either X or O. And that will be the winner. And we're going to use this pattern again and again. So copy, paste that. And this time it's going to be 3, 4, and 4, 5. Right? Yeah. And I'm going to make sure that 3 is not empty. And if so, return S3. So this one is going to be 6, 7, 7, 8, and make sure that 6 is not empty, and if so, return 6. So here are the 3 horizontal lines. And now for the vertical ones. I'm probably going to screw some of these up, I know it. Okay, so for the vertical one we have 0 and 3, 3, and 6. And as long as 0 isn't empty, turn S0. And you get the picture. So I will see you when I'm finished all this crap. Alright. So here is I think I have all of them now. 1, 2, 3, 4, 5, 6, 7, 8. Right, 8 cases. And the final default case, return empty. So So if there are no lines, then just return empty, meaning that no player has victory as of yet. Okay, so this is our check for victory. Pretty simple, just a bit of a bunch of logic tests. Like I said, there would be other ways of doing it, for example with loops and stuff, but it's probably not worth it in this situation. Alright. Now we can check for victory. But the problem is we have no way of showing which player has won. That's the what's the problem here? Alright, well, let's do this. XO state victory state is equal to check for victory. If victory state is equal to empty, meaning no one has won yet, then handle the user input and draw the cursor. So when the game ends, when one player wins, the cursor will disappear and you will not be able to do any more input. It'll just be game over. But the board will persist so that you can, analyze the positions and so forth. Let's see how that works. So we'll let X win the game here. X will play here. Then O will play here. X will play here, and O will be like, oh shit. And it worked. I can't, the cursor disappeared, and I can't do any more input or anything. So that makes sense, but I mean, generally speaking, we would like to have some kind of a message for the user saying, X wins or O wins. So, I have prepared some sprites that we can use. Let's see if I can find them here. Here they are. So I've got 4 sprites here. One is the toilet, because you can't have an end game screen without the toilet. And then we have 3 messages. X wins, O wins, and a tie. So it's just, your normal huge list of put pixel calls. And you just take those calls and you put them in a function with X and Y variables, and you're all set. So what I'm going to do is I'm just going to copy and paste them from my finished product. You can get the put pixel calls off of my forum as usual. I'm going to make a post, and I'm going to put actually all the downloads for every lesson in one post, and I'll stick you that to the top because it's getting kind of hard to find the material for the first few lessons. So I'll make a post and I will put that stuff in there. But for myself, I'm just going to copy and paste this stuff. So draw toilet. Copy. Where should I put it? I'll put it up here before the draw grid stuff. There it is. Draw toilet. It's a long one. And we'll just do these ones. Control C. This is going to be long. Bam. All right. This is the text for tie. And this is the text for O wins. And this is for X wins. So yeah, just make these 4 functions here. Let me get, I'm going to declare them. I'll put them up here. Where is it? Draw grid, draw toilet, draw X-win, draw O-win, draw tie. Draw end screen. That's a good one. Alright. So yeah, just make these functions and then copy and paste the stuff from the text files that you find on the forums into them. And you can have your end game messages. Now the last function here, draw end screen. Let's go back here. This one will pull together all of these different sprite drawing functions. So let's see it here. So the first thing we want to do is we want to draw the toilet. Draw toilet at XY. And next, if state is equal to X, in this case state represents the whoever won the game, I guess. The winner. I should have named it better instead of just naming it state. But whatever. Draw X win. We're going to offset, let me see here. Offset it to the right by 18 and down by 57. So it's going to go below the toilet. Else if state is equal to O, draw O win. My IntelliSense isn't working. Whatever. X plus 18, Y plus 57, same deal. Else, if it's not X or O, then it must be a tie. So draw a tie, X plus 18, Y plus 57. Alright, and then end. So you call this function and it should give you a nice end game message depending on what you... okay, what went wrong? XO state. What's wrong with that? Oh, okay, yeah. Again, how many times am I going to make this mistake? I'm just going to keep doing it. Syntax error. Okay, that's a problem. Too many curly braces. Okay, so now we have our draw end screen function, which will call some of these functions to draw our end screen. And now, let's go back down here. So if victory state is empty, that means we're still playing. Otherwise, if we are not still playing, we must be finished. Someone must have won the game. And in that case, what we want to do is we want to draw the end screen. And I'm not going to make a constant for the position of the end screen. I'll just put in some magic numbers here. And victory state. So we'll draw the end screen with the current victory state. Now, I want to move... no, I guess this is fine. This is fine. This is good. So now we should get a little bit of feedback when someone wins the game. Let's give it a shot. Yeah. And X wins. Beautiful. And just for the sake of completion, O wins. There you go. So that works perfectly fine. Unless, here's a problem. Oops. That wasn't supposed to happen. Damn it. Let's try this again. So X plays there, O plays there, X plays here, O plays here, X plays here, O plays here, X plays here, O plays there, X plays here, and what the fuck. The game is over. It should be a tie, but unfortunately we have no way of determining that the game is over. We only have a way of determining when one player or another has won the game. We have no way of determining the situation of a tie. So there's various ways to go about that. The easiest way, in my opinion, is simply to keep track of the number of turns. Because if 9 turns have passed and there's still no winner, then it must be a tie, because the board must be completely filled up. So we'll just go n turns, we'll initialize it to 0, and here we will continue doing user input and drawing our cursor if the victory state is empty and if n turns is less than 9. So if we hit 9 turns, then regardless of the victory state, we'll draw the end screen. So if the victory state is empty, meaning no one has won yet, the end screen will be it'll be a tie. And the best place to update the number of turns is right here at the end turn function. So we'll just go n turns plus plus, and that's a very nice, easy way of keeping track of turns. So the end turn function switches the active player and it increments the number of turns. Build solution. Alright, so now if we run a tie game here, we should tie. There you go. So now we basically have our tic-tac-toe game is finished. At least for 2 human players, it's finished. I mean, that's all you need to run the tic-tac-toe game. It's pretty much done there. However, generally when you make a computer game, you also want to be able to play with only a single player against an artificial intelligence. And yeah, so I'm going to show you guys how to implement a very rudimentary, very simplistic artificial intelligence routine. Basically the simplest one you can get. And that'll form the framework. And your homework will be to build a better artificial intelligence. So the artificial intelligence that we are going to be working with is the simple strategy of random choice. So the AI will just randomly choose an empty spot on the board and play there. It's the simplest strategy you can come up with, and one of the easiest to implement. But it can make for occasionally it can make for an interesting game. Usually it's just the computer plays in stupid places, and because it's completely random. What do you expect? So I'm going to make the AI routine. I'm going to break it up into 2 functions, and you might not understand why I didn't done it this way, but you will see later on. So the first thing I want is AI move X, Y. Alright. So these are going to be the moves of the artificial intelligence. I'll separate them from the other things, because this is all AI stuff. And I'm gonna add a function here. Void AI get next move random. We'll put it at the bottom here. That's fine. Part of the game object. Everything is part of the game object. It's not the right way of programming, but once we get there, we'll do things differently. For now, everything is part of the game object. Alright, so random numbers. To be able to use random numbers, you have to include stdlib.h. That's the first thing. It contains the random function. Now the random function, I'm just going to write the code here. And then I'll explain it afterwards. I think that's it. Yeah. Alright. So, a bunch of new stuff here. First thing, we have a little bit of a different loop here. Up until now, I've shown you while loops and I've shown you for loops. This is a do-while loop. It's very similar to a while loop, but in a while loop, first you test, and if it's true, you execute. Then you return and test again. In a do-while loop, first you execute, and then you test. And if it's true, you return and execute, and then test. So in a while loop, sometimes you will not even execute the body once. You will just skip it. But in a do loop, you will always execute at least once. So sometimes it's preferable to use a do loop, as in this case. But usually you can get away with a while loop. It'll serve your purposes in most cases, but sometimes you want to make sure you execute the body at least once, and then test and loop if necessary. So that's the first thing, a do-while loop. The next thing is the random function, rand. Now this random function returns a random number, and it's a number that could be like between 1 and something really huge. I don't even know what the maximum number. I think there's like max rand. Is that it? I forget what it's called again. Max rand? That's not it. I forget. Anyways, this random number function will give us a huge number, like a number between 1 and 2 billion or something like that. And obviously 2 billion is too much. What we're looking for is a number between 0 and 2, right? Because if you look on our coordinates, we have 0, 1, 2 for x and 0, 1, 2 for y. So we want a number between 0 and 2. But the rand is going to give us a number between 0 and like a billion. So how do we make it give us a number between 0 and 2? The answer is this operator here. This is called the modulus operator. And what the modulus operator does is it gives us the remainder of an integer division. Do you know what that means? For example, let's say I have the number 13 and I'm going to divide it by, I don't know, 3. What am I doing? Okay, this looks better. 13 divided by 3, right? So 3 goes into 13 4 times. 4 times 3 is 12. And subtract this, and we're left with 1. So the answer is 4 remainder 1. So if I was to do 13 divided by 3, the answer in C++ would be 4, right? Integer division. If I were to do 13 modulus 3, the answer is 1. We get the remainder, right? It's the same thing if I was to do, I don't know, 9 modulus 5. Sure, that's what I wanted. So 9 modulus 5 will give us, the answer is 4, right? Because 9 divided by 5 is equal to 1 remainder 4. So we get the remainder of the division of rand divided by 3. And the remainder will always be between 0 and the divisor minus 1. So it'll always be between 0 and 2 if we're dividing by 3. Because obviously if it was greater than that, then we could divide even more. So it wouldn't be a remainder anymore, would it? So this gives us the remainder of an integer division. And this lets us clamp our random value from 0 to 2. So we're getting a random value from 0 to 2 for our x, and another random value for y. And yeah. And then what we're doing is we're checking to make sure that the square at our random x and random y is empty. And if it's not empty, we're going to loop again. And we're going to keep trying until we find an empty square. At what point we quit. And then whatever's left in our AI move x and AI move y is the spot that the AI has decided it wants to move on. And that's the way that works. Okay, so that's AI get next move. Let's build this. Okay, it worked. Good. Now we want a function that will actually perform the move. This one is just to decide the move. So we'll do void do AI turn random. Do copy and paste here. Okay. So, there. So in the do AI turn, first we want to AI get next move random. First we calculate our next move. Then we set square state AI move x move x AI move y and active player. So we want to set the symbol at the square to the active player, which will be the AI player. And once we've set the square, just end the turn. All right. Now, that should be fine. Or not, because I fucked something up. AI. Why did I get next move? What did I do here? AI do AI turn rand is what I wanted to do. Must have copy and pasted the wrong thing. Okay, good. That's done. So now if we want to play against our random AI, we'll go to our compose frame thing here. And if, so we'll give the computer the first turn. If active player is equal to X, then do AI turn random. Else, do user input. We'll draw the cursor in either case. It won't matter. So now, depending on which player has the active turn, we'll either call the function to do the AI turn, or we'll call the function to do the user input. So the AI is played in the bottom right corner. We'll play in the center. Oh, we gotta block the AI here. And it's left us a nice option for winning. Start debugging. Yeah, the AI is played on the bottom right hand corner again. And it's played right again. And it's played top left again. That's weird. It's supposed to be random, but it's making the exact same sequence of moves every time, and that is not very random. And the reason for this is that our random function is actually not being random at all. It's outputting the same numbers every single time. Now, this random number generating function it doesn't give us true random numbers, it gives us pseudo-random numbers. It gives us a sequence of numbers that seems to have no pattern. But the sequence of numbers that it gives us will be the same every time unless we seed the random number function. We have to give it some initial starting state. And from then on, it will give us a sequence of numbers which seems to be completely random. But if we don't seed the numbers, or if we seed the generator with the same seed number every time, we will get the same pseudo-random sequence every time, which will not be random at all. It'll only seem random the first time, and after that, we'll be able to predict it. So we have to seed the random number generator with some arbitrary number that changes every time we play the game. So we can seed the generator in here. We call srand, and that will seed the random number generator. But we need to seed it with some kind of an unsigned integer. And the unsigned integer has to change every time we play, otherwise it won't be random at all. Now there are ways you could do this. You could have the user input a random number, and that will determine the game. But that lets the user determine, how the computer will play. So the user could input the same number every time and get the same game. And it's a pain in the ass, and generally that's not how you do it. Now there is another very convenient way of seeding. We'll include time.h. This gives us clock functions, lets us access the system time of the computer. And we'll call time with null. And this will give us, if we call time like this, this will give us, I believe it is the time in seconds since like 1970 or something. I don't know what it is. Maybe it's milliseconds. Or I don't know. But anyways, it gives us the current time. And we're just going to convert that to an unsigned int, because that's what srand wants. And the good thing about this is it's completely arbitrary what number will come. Depends on what time the user starts the program. And every time he starts, it's going to be a different time than the time before. So he's always going to get a different sequence of numbers. And so it will be quite random. So that's how we seed the random number generator. And you have to seed it just one time at the beginning of when the program starts. And after that, you'll get a nice random sequence of numbers. So this should work. Yeah, it worked fine. And now you see that the computer has tried playing a different place. It's getting aggressive, but not aggressive enough. And if I start a new game, I will seed... it's going to make a liar out of me. Well, you see, it made a different move that time. It's getting pretty aggressive there. I managed to force a tie. So now it starts at a different place. So you get the idea. It's nice and random now. I don't know. Play there. And yeah, now it's playing at the bottom. So it's very nice and random. All right, so that is that's the tic-tac-toe program. That's the basics of it. Anyways. All right, so let's have a quick review, and then I will give you a homework assignment. So we covered actually a bunch of new C language topics in this tutorial. So I just want to go over those quickly and make sure that you have a bit of an at least awareness of the new material that I've shown you in this lesson. So the first thing that I showed you is the switch statement, right? Switch and case. So if we go over here, where did I have a switch? Get square state, set square state. All right. Yeah, so you switch on a single variable, and I think it has to be an integer type, but I'm not actually sure on that. I'm pretty sure it's an integer. So you switch on a single variable, and then that will jump to the matching case. And if there's no matching case, it'll either jump to the default, or if there's no default, it'll just exit the switch statement. So very simple, but it's not as versatile as the, for example, an if else construction. So check for victory. For example, this one, you couldn't do this as a switch because it's not switching on a single variable. It's actually doing comparisons and stuff like that. So you couldn't switch in this case. You'd have to use if and else. But if it's just a simple, for example, if x is equal to 1, if x is equal to 2, 3, 4, 5, 6, then you could use a switch. All right, so that's the first thing we covered. Second thing, function overloading. That's very straightforward. It's just basically the fact that you can use the same function name for two different functions, as long as they have different parameters that are being passed to them. One thing that I didn't write on this list, but that we covered here, is returning values. This has nothing to do with function overloading actually, so I'll just put that over there. Yeah, returning values from a function. I don't think we've done that yet. I could be wrong, but I think this is the first time where we've actually written a function that returns a value. So in that case, when you're declaring the function, you, instead of putting void, you put the type of the value that's being returned. And in the function itself, let's see if I can find one here. Here's one. In the function itself, instead of just letting the the function go run to the end, you put a return statement here, and it will return a value. Right? Pretty straightforward, like this one here, return S0, S1, etc. So I think that was new. The next thing that I want to talk about is the enumerations. Right, we learned how to create new enumeration data types, and they basically allow us to map to map values to or to map arbitrary meanings to values in a variable. So we create a new variable type called exostate, and we say that it can take on 3 different values. So yeah, it's an alternative to just using a simple int and then, you know, having to remember that, okay, for this int 1 is equal to x and 2 is equal to o, and etc. Makes it a little more explicit and easier for the person to read afterwards, someone to read the code and understand what it's meaning. Next thing, we did constant variables. So we here it is. So instead of, I could have just declared this as a normal int, but instead I declared it as a constant int because it doesn't change. It's just it's a constant, like, you know, like pi or whatever. So in that case, you put this modifier in front of the variable type, and it will let you specify that this value should not change. It's set once, and it has to stay the same for the remainder of its existence. So you can put a little restriction on the variables, and it's good programming practice. If the variable shouldn't change, you should make it a constant. It will save you hassles later on. So yeah, constants, we'll use them more often. We learned a new function, or actually a few new functions, the rand, which allows us to generate a pseudo-random number. And we learned how to use the modulus. Oh yeah, that's another thing that we learned that I didn't write on here. We also learned how to use the modulus operator. Modulus. Yeah, so we use the modulus operator together with the rand to generate a number between, you know, 0 and whatever we want. In this case, it was 0 and 2 by doing mod 3. And in order to use random to get an actual or a kind of random sequence, instead of getting the same sequence every time, we had to seed the random number generator. We call srand. And we had to seed it with an unsigned integer value, which is just an integer that instead of going from, I think, negative 2 billion to positive 2 billion, it just goes from 0 to 4 billion. Whatever. The important thing is that you have to seed the random number generator with some arbitrary number. And to get that arbitrary number, we call another function which gets the current time. And we turn that current time value into, we cast it to or convert it to an unsigned integer. And then we use that to seed the random number generator. We only have to do that once when our program starts. And then our random number generator will give us a nice random sequence. And the reason we use the time one is because every time you run the program, it'll be a different, unique time. So you'll get a different and unique sequence of random numbers. All right. Last thing, the do-while loop. This is the third kind of loop that C has to offer. So I've shown you them all now. The for loop, the while loop, and the do-while. And the do-while is, like I said before, is basically the same as a while loop, except that it makes sure that you execute the loop body once before you do the test. So while is a pre-test loop, and do-while is a post-test loop. Where did I put that do-while anyways? I think it was in here. Yeah, here it is, do-while. Yep, okay, so that is all the stuff. We covered a bunch of new stuff in this lesson, but it was a long lesson, so I hope you learn something here. And I think it's time for your homework assignment. So far we've made a program that we can play with 2 human players or 1 human player against a pretty piss poor AI. For your homework, here are some other things you can try. This would be human versus... No, that's not good. Here is one I made. And this one, the algorithm is not random. It's a smart algorithm. So the computer will try to go for a win, and it will try to block the player when the player goes for a win. So it plays quite smart, and it won't lose. If it plays first, I don't think it can lose, actually. But it can win. Take a look at this situation. See, here it's got me. I can't win in this situation. If I block him here, he gets me there. So the first task is to make a better AI, an actual smart AI. So it's an interesting problem for you. Now the second thing is here is human plays first against the same smart AI, but I've made a little aesthetic change here. Now instead of the computer instantaneously taking their turn, what happens is it acts almost like a human is controlling the cursor. Now I'm not controlling the cursor for the O. That's all the computer's work. So it's just a little aesthetic change, but it makes you feel like you're actually playing against a real player instead of just a machine. So if you can make it so that instead of the computer putting down their piece instantaneously, instead they have to move the cursor, and there's delays in the time for thinking and stuff like that, it makes it a little, I don't know, a little more interesting, I guess. At least I think so. So that's another thing you can try. And here is just something where I put those 2 things together. So this is the random computer playing against the smart computer, but they both have a kind of those delays built in. So it's just an interesting little challenge. If you can get the first 2 parts done, then this is simple, but yeah, just a computer playing itself at tic-tac-toe. And yeah, so that is the homework. So just an overview of the homework. First thing, try to make a smarter AI. Second, try to make it so that the AI doesn't make its move instantaneously, but rather has to move the cursor and has a little delay built in. And this is trivial, just making it so that the random computer plays against the smart algorithm. Yeah, you can guess which one is the smart one and which one is the random. So yeah, do that, and that's your challenge. I'm not sure how much of this I'm going to go over in the next lesson or the next couple lessons. From now on, the next few lessons, we are going to be tackling probably the most difficult topics for C, the C language. Oh God, there we go. So we're going to be what we're going to be talking about in the next few lessons is, first thing, we're going to be doing arrays. And arrays will they will unlock a lot of potential for us. We'll be able to do a lot of crazy stuff once we get arrays. And we're going to be doing structures. I messed that up somehow, but yeah, arrays, structures. Structures are simple. It'll be trivial to explain that. However, the next thing that I want to talk about, pointers. This is the most difficult topic in C, I think. It's where a lot of people have their stumbling blocks. So I'm going to spend some time, and I'm going to spend some time thinking about it, and I'm going to spend some time explaining pointers. I'm going to try to do it in a comprehensive and accessible manner. So, and once we learn pointers, then we're going to be doing, we're going to learn about character strings, or just strings, which is text, right? And I think when we do character strings, we're going to be doing that in the console mode. So we'll learn a little bit about making console application. And once we do that, then we'll do file access. That's just learning about a few functions. And memory. I can't write word shit here. Memory allocation. And once we learn all this stuff, then we'll be able to load images into memory and draw them. So we'll be able to like get bitmap images and use them in games, instead of all that put pixel, like hundreds of lines of put pixel code. We'll be able to algorithmically load images from a bitmap file and use them in a game or something. But in order to do that, we've got to cover all this stuff. So we have a little while to go, but it can go by pretty fast. Arrays are very big. This will allow us to do a lot of cool stuff. And so forth. So that's the roadmap for the near future. Hopefully near future. I've had a lot of stuff going on in real life, so I haven't been able to make videos that often, not nearly as often as I would like. But hopefully I'll get some more time and we'll be able to make good progress. And I mean, once we make it down to here, that's basically the end of the C language for us. We've learned everything that C has to offer. So after this, it's all C++. And once we learn a little bit of C++, not a lot, but a little bit, then I will start teaching you guys about the framework, about how DirectX works and how Win32 works in the framework. I'll explain how the framework works, because I know a lot of you guys want to know all about those the inner workings. So we'll get there. But first, we've got to conquer C. And yeah, so I guess this is Chili signing out, and see you in the next lesson.